Okay, greeting guys. I hope you are doing well. Today I would like us to deal with problems that deals with nature of a root. So here we are given a problem that says that open bracket p plus 1 multiplied by x squared plus 2px plus into bracket p plus 2 is equal to 0. So the first question says that determine the value of p if the roots of the equations are equal. Okay, for this problem, there are a few things that we should recall when working with a nature of root. We are talking of a determinant which is equal to, okay, I won't say it is equal to, but a determinant is being derived from our quadratic formula that we know that says that x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. But when we talk of a determinant, we talk of this part that is inside. So a determinant is denoted by theta, which is equal to b squared minus 4ac. Okay, so the question says that determine the values of p if the roots of the equation are real. Okay, are equal, not are real, are equal. Okay, in this scenario, you have to write this scenario in the standard form, of which is ax squared plus bx plus c. Okay, of which is equal to 0. So you check the term that correspond to a, that means your a is equivalent to p plus 1. Okay, your b is equivalent to what? So this is the only coefficient of x, of which is 2p. And c is a constant, that means it does not have x, so it means p plus 2. Okay, to answer this question, if they say determine the value of p if the roots of the equations are equal, when does roots becomes equal? Roots are only equal if determinant, of which is b squared minus 4ac, is equal to 0. So only if a determinant is equal to 0, that's where we claim that, okay, the equations or the roots are equal. Okay, so provided that we know the value of a, the value of b, and the value of c, now we are required to calculate the value of p. So meaning we rewrite the equation b squared minus 4ac being equal to 0, and our b here is represented by 2p, so it becomes 2p squared minus 4. Our a is represented by p plus 1, that means p plus 1. Our c is p plus 2, p plus 2 being equal to 0. So here you get 4p squared minus 4. Open square bracket, you multiply this thing, p plus times p, it becomes p squared, p times 2 becomes plus 2p, and 1 times p plus p, that means 1 times 2 to be plus 2. of which is equal to 0. So here you have 4p squared. So you distribute 4 throughout. 4 times p becomes minus 4p squared. Minus 4 times, okay, here you see that when you add that you get 3p. And then 3p times 4, what becomes minus 12p. Yes. Minus 4 times 2 becomes minus 8, being equal to 0. Okay? So from here, you see that these two cancels. So we are left with minus 12p minus 8, which is equal to 0. That means minus 12p is equal to 8, and then we divide by minus 12 both sides. Okay, so here we're left with p, which is equal to here. So which number divides both of the two? That means it's 4. 4 divide 8 2 times, and 4 divide 12 3 times. So it becomes minus 2 over 3. That is the value of p. Okay. Let us verify that the value of p is correct. How do we verify that? When you decide to plug this value here, it should give you 0, of which is something that is possible. Okay, so here if you say, let's just go back here, let's just replace p with minus 2 over 3. So that means your a is equal to, so here it's a checking. Check or you are verifying. Okay, a is equal to minus 2 over 3 plus 1, of which is equal to 1 over 3. Go for b. b is equal to 2 times minus 2 over 3, of which is minus 4 over 3. Okay, we go for this one. c becomes minus 2 over 3 plus, how can you write 2 making it, okay, we can say 2 times 3 over 3. So it's like a multiplying by 1, which is something that made no difference. We just want to have same denominator, of which is 3. So here it's become minus 2 times 3 becomes plus 6. So you end up having minus becomes 4 over 3. Okay, I said to you, for a root to be equal, b squared minus 4 ac should be equal to 0. So here, this is your b, so it becomes minus 4 over 3, you square it, minus 4. Where is our a? Our a is 1 over 3. It's 1 over 3. Our c is 4 over 3. 4 over 3. Okay. So this one, minus 4 squared becomes 16. 3 squared becomes 9. So you have 16 divided by 9. Okay. Minus. So you see that 3 times 3 becomes 9. Minus 4 times minus 4 becomes 16 over 9. So 16 over 9 minus 16 over 9 becomes 0. That means indeed our left hand side is equal to our right hand side, of which is equal to 0. So p is equal to minus 2 over 3 is the correct value. Okay. So now we're required to determine the value or the values of p, provided that p should be different from minus 1, so that the above equation has roots which are real, rational, and unequal. Okay. So in this scenario, we go back to the definition of what is meant by real, rational, and unequal. Okay, my apologies, I did not number my solution. So this one is 1.5.1. So the one that I'm doing now is 1.5.2. Okay, 1.5.2. The roots are said to be real if determinant is greater than or equal to 0. The roots are said to be rational if it can be written as A over B, provided that B is different from 0. And the roots are unequal provided that theta is strictly greater than 0. Because here you have two conditions, either it's greater than or equal to. Here it's only greater than 0. So by being rational, that means whenever you're trying to find the square root of the determinant, you should find something that can be written in the form of a fraction. Not sure whether that one is clear, but I hope it is clear. Okay. So here, you have to determine the values of p, provided p should be different from 0, so that the above equation has roots which are real, which are rational, and which are also equal. Okay. So first thing first, the fact that we know that this one, if p is equal to minus 2 over 3, it gives us equal roots. That means, what is it that do we need to find something that is greater than 0? Because this one gives us something that is equal to 0. Meaning we should find something it's either less than this or greater than this, but provided that it won't be equal to minus 1. Okay? So let us go back here. We said b squared minus 4ac. Now it should be greater than 0. Here we get something that is equal to 0. Alright. That means let us twist our value of p, check something that is greater than this one. Something that is greater than this one, it is minus 1. Let me check. Oh no, minus 1 is less. So something that is greater than this one is minus 1 over 3. So let us check for minus 1 over 3. If we can plug minus 1 over 3 instead of x, meaning our a will be equal to minus 2 over 3. Let me show you. Because our a is equal to what? Our a is equal to, our a is equivalent to p plus 1. So let's just check. I said we are checking for the value that's less than this one. So the near one is minus 1 over 3. You say plus 1, that means you get 2 over 3. Let's go for b. B, I said that, where is b? B is 2p. So if you say 2 times minus this one, just becomes minus 2 over 3. So let me check for c now. C is p plus 2, of which is our p. I said our p. Please, I said let p be equal to minus 1 over 3, of which is the value that is greater than that one of minus 2 over 3. So now let us check. So it's minus 1 over 3 plus 2. Just multiply this thing by 1. But this one of mine will be 3 over 3. of which is minus 1 divided by 3. So this one times this one becomes plus 6. So it becomes 5 over 3. See, so let me check whether if I try to find a determinant for these values, am I getting something that is greater than or something that is less than 0? So it's b squared minus 4ac. My b is minus 2 over 3, squaring it, minus 4 times what is a? A is 2 over 3. What is c? C is 5 over 3. Okay. So here I'll get 4 over 9. And by default, c 2 times 5 becomes 10. 10 times this one becomes minus 40. Yes, over 9. So by default, I see that the number that I get is less than a 0, of which does not satisfy this condition. Does not satisfy this condition. It violates this condition, meaning I cannot make p less than. I cannot make p greater than 2 over 3. So meaning this one is not correct. This one is not correct. Should try something that is less than this one. But provided that being less, it should not be equal to minus 1. So let me check something that is greater than minus 1. That is less than minus 1. Let me check minus 2. So if my p is equal to minus 2, let p be equal to minus 2. So, okay, start with my a. A is equal to, as my value of a, my a is p plus 1 if I'm not mistaken. Yes, p plus 1. So it becomes minus 2 plus 1. So my a becomes minus 1. Let me go for b. B becomes what? 2p. So my p is minus 4. Because when you are saying 2 times minus 2, you get minus 4. That's why I came with this one. So, and our c is equal to p plus 2. And my p here is minus 2 plus 2, of which is something that's equal to 0. So my c becomes 0. Okay? So that means I can find b squared minus 4ac. How do I find it? B squared becomes minus 4 squared minus 4. My a is minus 1, but my c is 0. So here you see I get 16, and this one is minus 0, so it's equal to 16. And 16 is greater than 0, so my b squared minus 4ac is greater than 0. So by default, I can write that if they say they want the values of p, they want the values of p. They want the values, okay, because they want me to determine the values of p, but p should be different from minus 1 so that the above equation roots are real, rational, and equal. So that means my p should be greater than, should be less than minus 1, sorry. Should be less than minus 1. Should be less than minus 1. Because here you see that I just used minus 2, and minus 2 gave me 16, And 16 can be, okay, a square root of 16 is 4, and 4 can be written as 4 over 1. So yeah, that's why I said when my p is less than minus 1. And also I should include that my p should belong to natural numbers. Not natural numbers, sorry, but my p should belong to integers. Thank you. I think this one was a bit challenging, but I believe you will try to understand what was happening. Thank you.